Hi everyone, the topic of our API project is real-time visualization and statistical analysis on New York City subway system data. The motivation came actually from our recent visit to New York during last winter vacation. Of course, we visited the Times Square and it is the busiest station in USA. So many people were traveling, so many trains were passing through. So we thought it would be kind of cool to be able to track those trains in real time. This script reads the Metropolitan Transportation Authority real-time feed API for subway data, which are updated every 10 seconds. The MTA is the largest public transit authority in US, which is responsible for public transportation in New York City. It receives GTFS station ID, subway route ID, arrival departure time of the trains, latitude longitude of the stations, and subway timetable as inputs. It shows a map with all routes and all stations with the real-time updates of the latest 5 departures and arrivals for each station as output. It also generates probability distribution plot of delays, inter-arrival times, and expected time to next arrival for two particular stations, Times Square, 42th Street, and Atlantic Avenue, Barclays Center. Here we can see all routes and stations on MTA subway. And here we can see all the stations for route 1 on the left side and for route B on the right side. This is one of the output of our projects, which shows the latest 5 departures and arrivals of Times Square station.
Here we are describing some requirements from our code. In resources of our README file, we have listed some references which we found useful for our code, and the 2 CSV files we will require for our code. For running this script, we will require protocol buffer compiler and some Python packages, which are GTFS real-time bindings, protocol buffer 3, Google, Folium, Seaborn, and transit feed. The installation procedure is described in the README file in detail. For the access to these live feeds, we will require signing up and getting an API key from NYC MTA. Then the key needs to be set as an environment variable named MTA_key. It also requires to keep the 2 CSV files where the Python file is saved. Here are some instructions for how to run the code. We will require MTA API key and installing necessary Python packages. Then by opening the Python file provided and running the cell sequentially will work. Now come to the explanation of the code. At first we are importing the necessary packages in our script. After parsing feeds from the feeds, we merge them into a list named real-time data. For the purpose of explanation, we divide our code into 3 phases. In phase 1, the first function we have used here is the station time lookup. This function takes 2 arguments, the real-time data as train data and a dictionary containing the GTFS stop IDs of different lines of all stations. This real-time data is a list containing nested dictionaries and lists. So looping through the elements of real-time data and comparing with stop IDs, we are taking times and routes data. Then the next function is sort by times, which takes 2 lists, routes and times as inputs. It merges them into a list called routes plus times containing routes and times in a tuple as elements of the list. Then it sorts the routes and times based on arrival times, which is the second element of the tuple using take second function from latest to oldest. The sorted routes and the times are then appended in list sorted routes and sorted times respectively. Then we called our function with required inputs here and divided the routes and times between departures and arrivals. Finally, we visualized the data to generate these plots, revealing the latest 5 departures and arrivals for all stations from possible routes as output. For the purpose of plotting routes, we are using color code for each set of lines specified by MTA.
In phase 2, MTA routes were plotted using a CSV file named stations_modified.csv, which is generated from subway stations documentation for the ease of plotting. The routes and the stations will be plotted using the station name, route name, stop sequence, latitude and longitude information from stations_modified.csv. The departure and arrival information will be shown as pop-up figures generated in phase 1 of this code and stored in the same directory as this script. The map will be saved as mta_routes.html. We created a base map by passing starting coordinates to folium. We used CartoDB positron tile layer to better visualize the routes and stations. The following loop creates a circle marker, assigns name, and creates pop-ups for each station. Station name are shown using a div icon, a lightweight icon for markers that uses a simple div element instead of an image. Figures are shown as pop-ups using iframe. The figures are first encoded in base 64 and then converted to HTML. The map is saved as a .html file. Here we can see the map showing arrival and departure information of Times Square station. Phase 3 requires two new functions named vehicle_lookup and next_whole_minute. The first function takes the same input arguments as station_time_lookup and generates a list called timestamp containing the epoch times of vehicles stopping at each station. The next_whole_minute function takes an epoch time as input argument and returns the next whole minute. Using the scheduled arrival times for Atlantic Avenue, Barclays Center, and Times Square 42nd stations from mta_schedule.csv and the timestamp from real-time feeds, we calculate the delays, inter-arrival times, and expected time to next arrival to show in the plots.
So we have made some suggestion, and there more data can be gathered for reliable statistical analysis, or the statistical analysis could have been shown for all stations, and the script running time could have been made faster. So thank you all for watching.